Greetings, everyone. This is for the fall semester Harvard Extension course, uh, Scala for Big Data Systems. This is Srinivasan Maker. I'm presenting my project here, which is more analyze the CDC COVID-19 data, and the data set is obtained from CDC website. And we have about data population. This is the URL used. And we have about 103 million records and about 14 GB data file. And for getting control of the data, initially I had to split and then into files uh, and start analyzing it. And I'll just get a brief overview of the data set itself. This is the data set from CDC for the COVID-19, which de-identified patient data, which is about 103 million records. And you can see the schema itself with all the 19 columns which are used. And there's no any NPPI. It is mostly desanitized data. And we are used a Scala as well as IntelliJ IDE and as a development platform, and Apache Spark as a distributed computing platform, and as a local environment. And this same implementation has been done using AWS EMR and S3 as data lake as a HDFS file system. I'll briefly go over the design of it. We are using the Lambda architecture here, uh, and different layers of it. I would explain in detail in this diagram. We are taking the data, as you can see, we are taking CDC de-identified data from CDC, and that big file with 103 million records or 102 million records has been split into smaller files. So you could experiment with the smaller files, so you know what you're dealing with, and so you can do more faster development and then see your results. And here we are using as a data ingestion layer as S3, and you can see the S3 here. And this is where we upload the source code. We have multiple directories in the S3 bucket, and the source will have the jar file, and similarly we'll have the data files. The split all the files, which are 14 GB files, are split into like 10 files. Each file contains about 10 million records, and you can see like starts with AA, AB, AC, AD like that. And once you start processing, and the processing you need to do through EMR, which is an elastic map reduce engine to instantiate the master and the workers. And here we're using Apache Spark and HDFS, Hadoop as the file system. And that is the S3 here. And you can execute some steps, like you can launch the scripts. Uh, but like again, there's two ways. You can set up the steps and what jar file you can execute, or there's other ways like to execute uh, through the Unix. You log in into the AWS EMR using SSH, and then process the files. And while processing the files, you can see it is processing from the S3. It's picking up the files here, and you can see all the 13 or 14 files which are processed, and generates the results. And you can see the command is like you can submit through Spark submit and the jar file, and it launches all this, process all the files, and generates the results. Uh, and you can the results are like you can put them in the Parquet file format. Like I'll show you here, like Parquet file format, like because that's much more efficient, and so you can reprocess those files much faster than processing a CSV file. But here in this case, what I did was later on of the design, I decided to go put those into a temporary view inside the Spark session and share this Spark session across the parameters to all the different methods. So you don't have to repopulate the data from the files, but you rather use this view across and do your query analysis and get your results and write the results uh, into the output directly. I'm showing a local environment here, and your output would look like this. Uh, like you write your output, and when you run the process, the jar file, it automatically generates all these different directories where you are analyzing different results. Like if you want to see by state, how many patients have been identified and how many of them, how many deaths happened by state. And you can see these are the by state how many patients have been reported and how many deaths happened. And if you can randomly see, like in California there was about 72,000, but this is as of the CDC data which we processed, could it be more based on 2023. And these numbers look right, and this is the information how the results are stored here. And and the output, like for each directory will have different query conditions, and each method will generate a file based on your different criteria, analysis criteria. And survival rate by age group, and like suppose you want to see how many people uh, had deaths with existing conditions, or how many total patients were there, how many are lab confirmed, and how many people recovered even after their infection. Those kinds of different scenarios based on the different age groups we can see. And on what are the recovery cases, you can see there are less recoveries in case of 65 plus years. And those are the analysis which you can do using Spark as a distributed computing environment. And that is the end of my presentation.